Hello friends, this is our fourth video in our complete Terraform tutorial series. We have already covered a lot of topics so far and we will continue to cover more topics in future. So in this session, we will be using Terraform to completely create an AWS Cloud infrastructure that is specifically a VPC. I have already documented everything related to this topic and I will provide you all the relevant links in the description. So make sure to use of it. And we have uploaded a lot of videos related to multiple technologies like Ansible, Jenkins, Kubernetes, Docker and many more. If you are interested in learning, then please do subscribe now and click nearby bell icon so that you will get the notification of the new videos. So if you want to create an infrastructure like AWS VPC or any huge infrastructure, so we need to list out and create everything based on the architecture. So when you look at this architecture, we are not just creating a VPC. There are multiple resources involved in it like subnets, route tables, security groups, internet gateway. So we need to identify or list all these first. After that, we can see which resources are suitable for Terraform and we will write our manifest file accordingly. Since we are focusing on the VPC, I am going to create a dedicated file called vpc.tf. Also, I have already commented out our previous manifest as our focus is only on VPC. And in the provider section, if you see, I have specified US East 1 since I am creating the VPC there. So we have created a file called vpc.tf. So in this file, let's list out all our resources. The first resources we need to create is the VPC. Then next, based on our architecture, we need to determine how many subnets that we need. In this case, we will have both one public subnet and one private subnet. So if you want to create a public subnet, we will need an internet gateway. Then only it is called as a public subnet. So we will add that as a second resource. Let's take the third resources. See, we have created the VPC and the internet gateway. So the main resources we need here is subnets. So if you look at the diagram, we require two subnets, right? One is the public subnet and the private subnet. For the public subnet, I will create a resource called public subnet 1. Next, I will create the private subnet, which I will call private subnet 1. Now, the fifth resource is for each subnet, we need to create a route tables. So route tables are essential because they ensure the traffic is forwarded correctly. So I will create one route table for each subnet. For the public subnet, I will create a route table called public route table 1. Okay, public RT1. So similarly, I will create the other resource called private route table 1, that is for private subnet. So at this point, we have created 6 resources. If you create multiple subnets, you must associate the relevant route tables with them. Then only the traffic will be forwarded to the correct subnets. So when we attach an internet gateway to a subnet, then that subnet will be a public subnet. So for public subnet 1, I will set up the internet gateway attachment. So we will not attach the internet gateway to the private subnet. If you attach the internet gateway to a private subnet, then that private subnet will also behave like a public subnet. So that is wrong. So we have to attach the internet gateway only to the public subnet. The association between each resources is more important. So public subnet 1 association. Okay. And this public subnet 1 association I will be using to attach my internet gateway to the public subnet. Similarly, I will do the same for private subnet, but here I will associate private subnet with the corresponding route table. I don't attach any internet gateway. Anyway, I will list the resource like private subnet 1 association. As per this list, almost the VPC and the main components will be created. So finally, we will deploy the servers. For public subnet, we will deploy public facing servers like web servers. And for the private subnet, we will generally deploy the backend services like database or any application servers. Right? So we will be deploying 2 servers, one web server in the public subnet and one database server in the private subnet. So when we create EC2 instance, we will also need a security group. So security group are very essential to control the access rules such as inbound and outbound traffics. Now, for the next resource, I will create a security group called SG1, Security Group 1. So this will allow access from anywhere, but also I will restrict some access to my specific IP as needed. In EC2, I will mention a server for the public subnet called Web Server 1. Similarly, I will create another EC2 instance for the private subnet that will be called as DB Server 1. We have a total of 11 resources to create now. So this is the concept we are going to follow. So let's identify all the resources that we have listed here from Terraform. Let me comment out all these lists. I will start associating each resources accordingly. So already I have opened Terraform registry. The first resource on our list is VPC. So search for VPC. Mostly it will be under Virtual Private Cloud. So just expand it and use the respective resource. Already we have covered all these topics like how do we choose the right resources from Terraform, right? Okay, so this is the right AWS VPC resource that will be used to create VPC on AWS. So here is the syntax. The resource name is a VPC reference name and it provides a CID block. So this is what we need. You will have many options available in these specific resources. Instance tenancy, DNS support and many more options like this. So we have to choose the right options if you need anything additionally. So I'll just copy this basic syntax and I will paste it under the list. Okay, if you see here the resource name, you cannot change it. So this is a reference name. This is an example. As we have copied from the Terraform registry, they have mentioned like main. Then we have to give some unique name like VPC1 and VPC2. So that will be easy for us to track. Okay, so I have given VPC1. The CID block is 10.0.0.0.16. So let it be the default value. From there we are splitting the subnets like one series for public subnet and two series for private subnet. Even if you create the VPC manually, obviously this will ask you to enter the name and CID block. And in the statement, we have not defined any names, so the name will not be created. So we have to define the name manually using tags options. If you check at the Terraform, there is a syntax for defining the tags. So just copy the tags and paste it inside the section. Here, in the name, you can give some name. Let's say take an example like you are creating this VPC for a Coke customer or a Flipkart customer. Accordingly, we need to define it. Then only if you go to AWS and listing all the VPCs, it will have a unique names. Also, I will add one more tags called managed by Terraform. So if anybody going and seeing the tags, it will be mentioned like it is managed by Terraform, so nobody would change it manually. Otherwise, you can keep your team name like managed by dev teams, DevOps teams. This is a general practice we follow. When you create such high-level infrastructure, create each resources one by one and apply it. If there is any issue, you can resolve it. So overall, if you write everything and if you do apply, you will encounter multiple issues, then it will be challenging for you to resolve it. That is why I suggest create each resources and apply it, then resolve the issue if you have anything. So let's Terraform apply. So it is applied. Let's refresh the VPC. So as I expected, the VPC is created and we have given the name in the tags, that is Coke VPC. If you have not specified the tags, this name will not be appeared here as expected, so then we will get confused. That is why we suggest you to follow all the practices. So as we expected, the VPC has been created and the CIDR range is created. So the next resource is Internet Gateway. So we are going to find out the resource for the Internet Gateway. Now, if you look here, try searching for something like Internet. So it will show you all the list that is matching this pattern. So there is an internet gateway resource. I will open it. So if you look here, the resource has a resource name. They have given a unique name for the gateway. If you look at this internet gateway is attached to a particular VPC. So even when we create it manually, the same concept applies. Okay. So we have to attach the internet gateway to a VPC ID. Okay, just copy and paste it here and just update it whatever we want. On the unique name, I will just make it internet gateway 1. On the VPC ID, we need to call as per our section VPC resource we have created like AWS underscore VPC, then VPC 1. So we have to change it accordingly. So the ID will be automatically associated. And if you look at the tags, the main one is general, since we have copied from Terraform registry. So we are creating this VPC for Coke customer, right? So I will create it as Coke-Internet Gateway 1. Similarly, I will provide managed by tags as well. Okay, save the manifest file and let's do the Terraform apply. Okay, the apply is completed. Let's go to VPC and refresh the page and go to Internet Gateways and see the Coke Internet Gateway 1 is created and it is exactly attached to the VPC ID we have mentioned in the section. Here if you see, we need to do some improvisation over here, like for every resource we are using the tags called Coke. So when you create multiple resources like 10 resources or 20 resources, then you need to mention everywhere. So that's why we are using a variables. We already have a variable.tf file where I have mentioned a variable for my instance type. So again we need to create a section called variable. So already we have covered Terraform variables in the previous discussions. Okay, variable client name and variable managed by. So I can use these variables in any Terraform manifest file further. If you want to give any default values, you can give it or you can ignore it. Let me give some default value. I'm going to completely manage these variables in terraform.tf verse. Okay, I'm creating this variable section now only for dummy purpose. If you don't have a variable sections, you will have an error from Terraform. Like there is no variable section for a variable you have referred, right? That is why I just creating this variable section. So let me give some default value, like default. It doesn't matter for me. I will manage everything through tf verse file. Similarly, for managed by, I will give default equal to some names like devops. If I didn't any values in tf verse file, then obviously this default value will be applied. Let's go to tf verse file. Let's define the client name equal to Coke and managed by equal to Terraform. Now go back to the VPC Terraform manifest file. We need to update the names along with the respected variable names. So I will use dollar parenthesis and within the parenthesis I need to give the respective variable name. So as I have given client underscore name, the value of client underscore name in tf vas is Coke. So this resource will be created like Coke-VPC. So if I want to change my client name, I don't want to go to every resources and modify the values. Simply I can come to this tf verse and I can change the client name to something else. And if I do apply, the names will be changed accordingly. Also I will change the managed by as a variable. I will copy this tag. Similarly I have to use in every sections. Let me copy the name and managed by. And if you see this name, it is not a VPC, it should be Internet Gateway 1. As I said before, in case if you want to change the client name, simply come to this tf verse and just change the client name or any other variables. So this will save us a lot of time. Let me apply this. Alright, so we got an error like managed by and within double quote. Okay, I have mentioned the variable within the double quote. So this will consider as a string. So it will print as it is. Since this is a variable, we have to use var dot then variable name. Then only the particular variable name will search for variable section and the value will be applied. Okay, done. Save the changes and apply it again. Now go back to console again and just refresh the page and make sure all the changes are there as per our Terraform manifest file. Alright, now let's go and create the other resource. That is public subnet 1. Let's go back to Terraform registry and find the respective resources. Search for some pattern like subnet and it will list out all the matched result. Okay, it should be under VPC. Let's use this AWS underscore subnet. They have mentioned the unique name, VPC ID, and the subnet should be attached to VPC ID and the CID range for the subnet. Okay. So just copy this, paste it over here, then make the changes. So let's change this unique name to something else. Since it is a public subnet 1, I will give pub underscore subnet 1. VPC ID. So again we have to use the interpolation model. Already we have used the same VPC ID reference in internet gateway. So just copy that. And CID block. As per our environment, public subnet should be 10.0.1.0/24. Already it is there. So let's not change anything. And for tags, let me copy from the previous section. Just change the name to public subnet 1. Then only this particular resource will be created with the coke-pub underscore subnet 1. Okay, so we have defined the resource section for public subnet 1. For private subnet also we are using the same resource. Okay, only difference is we will not attach the internet gateway. So just copy this syntax and paste it under private subnet 1. Now just make the changes. Here on the name, instead of pub, it should be private. So just change it to meaningful name, private underscore subnet 1. So VPC ID is perfect because this subnet should be attached to the VPC ID that we are creating through Terraform manifest file. The CID block range would be different for each subnet, right? For public subnet, we have used 1 series. For subnet, private subnet, it should be 2 series. And tags, yes, we need to change the name. It should be private. Okay, let's apply this. So it is applied. Let's go back to VPC again, refresh the page and go to subnets. Already I had some default subnets. Along with that, we have got our newly created subnet for Coke. And both subnets are attached to Coke VPC. If you click public subnet 1 and go to route table, see there is no route tables here. These route tables are default route tables created for the specific VPC. Now we need to create the additional route tables. Again we need to go to Terraform registry to find the right resource. Let me search for route and here it should be under VPC obviously. Okay. Here route table. Here if you see this example, they have route table and multiple sections. So obviously the VPC ID will be there because we need to attach the resources to a specific VPC ID. After that, if you see, we have a route. So this route is connected to a internet gateway. So when you attach an internet gateway to a subnet through route table, that subnet will become a public subnet. That is why we attach this gateway. We have another route record that is for IPv6. We don't want these route rules. Okay. Then tags. Just copy this entire section and paste it here. From here we will update it. The first thing, we will change the name. Since it is a route table, I will give public route table because this route table will be used for public route table. For VPC ID, let's use the same VPC ID interpolation model. And on route, we don't want this IPv6. Let me remove it. on this route table. So we have to attach the internet gateway to a public subnet through route table. That is why we need this route section. On the CID block, it should be like 0.0.0.0 because this is the internet gateway route rule. Anybody can access to our public subnet from anywhere. So we will generally give 0.0.0.0. If you see my default public subnet, see the route table 0.0.0.0. They have mentioned for internet gateway. Anybody can access it. So how do we restrict access? It should be handled through NACL, that is network ACL or security groups. On gateway, again, this is the interpolation model. Already on the second resource, we have created the gateway resource, internet gateway resources. So we have to call the respective internet gateway ID through interpolation. So obviously we will use the AWS internet gateway. The name is internet gateway 1. So we have to change it accordingly. So the name should be internet gateway 1. Now the tags. Simply copy the previous tags, paste it here and just change it. And this is a public route table 1. Okay, next again it is a route table, but this is a private route table. So simply copy the resource section from public route table 1 and paste it here and do the changes. The name should be private. VPC ID is same. For private route table, we don't want the internet gateway attachment. If you attach this internet gateway to a private subnet through private route table, then it will be a public subnet. So don't do these mistakes. Okay. So let me remove this. We don't want this attachment. And tags, just make the changes. I'll call this as a private route table 1. If you go and check my existing private subnet, see, it has only the default route rule. I don't have any internet gateway. Similarly, I am following this practice. Okay, so now we have created the route table resources, public route table and private route table. So let's apply these changes. It's applied. Now again go back to route tables and refresh the page to make sure the route table is created or not. Now we have a public route table and private route table, and now we need to verify all the things like whether the attachment has happened correctly or not. So just select the public route table 1 and see the internet gateway is attached and it is 0.0.0. This is expected. If you see the private, there is no internet gateway. Now we have created the subnets. Also we have created the route tables. Now we need to associate the respective subnets and route tables. Then only the traffic will be forwarded to the right subnets through this route table. If you see this public route table, there is a tab called Subnet Association. Here we generally select the respective subnet using this Edit Subnet Association. Similarly, we have to use the same subnet association using Terraform. So we are going to associate the public subnet 1 with public route table 1. Same way, we are going to associate the private subnet 1 with private route table 1. Let's go again back to Terraform registry and search for subnet or association. Okay, let me search route because the association will be done through route table. Okay, under VPC, if you see, there is a AWS route table association. Okay. These are default and main route table association. We have to use a dedicated route table association. Click on this resource. See the example. As usual, they have the resource name and some unique name. They have mentioned A, and here simply they have mentioned the subnet ID and route table ID to associate. Simply copy and paste it here. Just update these resource. On the name, I will mention like this is for public subnet 1 route table 1. So I will use public subnet 1 underscore route table 1. So be clear with this. This route table is for public subnet 1 and route table 1. Here they are using the interpolation model. Already you have created the subnet and route table in the previous resource definitions. Simply you have to call the interpolation model and update the values here. just scroll up and see the exact name you have given. It is pub_subnet1. For private, I have used prive_subnet1. Okay. Instead of foo, just update pub_subnet1. Similarly, for route table, again, find the correct name you have given. Here I have given pub_route1. Similarly, I have to update it here. That's it. This will associate your subnet and route table. Simply copy this and paste it for private subnet associations. Here I will change the name. This is for private subnet, so I will change it to PRI, and we have to update the respective subnet ID and route table ID for private. Here I will change it to PRI. Here also I will change it to PRI because we are following the same naming standard. Now we have defined the resources for associations and let's apply it. It is done. Now go back to VPC and so let's refresh it. Select the public route table 1 and go to subnet association. Here if you see, as we have defined in the Terraform, for public route table 1, public subnet 1 is attached. This is what we expected. Similarly, if you see the private route table, the private subnet 1 is attached. As per our infrastructure diagram, we have created the VPC, we have created the internet gateway, then route tables. Also we have created public subnet and private subnet. So almost we have created all the components that is needed for this VPC diagram. Now we need to test it using some servers. So we have to deploy EC2 on public subnet, also on the private subnet. So 9th resources I have mentioned like security group. Then only you can handle your traffic. That is why I have mentioned the security group before creating the instances. Let's find the right resources here. Search for security or something. Under VPC there is a default security group. Also we have a security group. Okay. We are going to create a new security group, not default. So we have to use this AWS security group. So this is the basic example of creating the security group. If you see the security groups, manually if you are going to create it, what is needed? Two things. One is inbound and outbound. Inbound is nothing but the traffic coming to your security group. Outbound is nothing but the traffic going outside of your network. So generally we will restrict or give more control to inbound. Then only we can manage or control our traffic. Who is needed to access our network. Outbound is nothing but we are trying to access outside the network. So it can be 0, 0, 0, 0. That doesn't matter. So inbound and outbound on security groups. But in Terraform, they refer it like ingress and egress. For inbound, they refer it like ingress. For outbound, they will refer it like egress. Similarly, if you want to give any rules like inbound or outbound, you need few values like type and protocols and port numbers and the source. Okay, if you see the example, that is a name, security group, and allowed TLS. That is just a name. We can give anything like security group name and name. This is just a description, like when you click on the security group, that will have some description to identify why do we create this security group. For that only they have this description field. If you want, you can keep it or you can ignore it. Then VPC ID. Obviously we need to attach the resources to a specific VPC ID. So they have this value. Then tags. Okay, if you see these resources, they are creating the security group, but they don't have any rules like for inbound and outbound. For that only they have additional resources to create the rules. If you see from port, IP protocol to port, which security group. So these are the required fields that we need to add in a rules. Also we have another formats instead of using a dedicated resource for creating a rules, we have a pattern called egress section and ingress section. That also can be used. Both will support. Which is easy for you, you can use it. Okay. You can go with resource section, or simply within the security group, you can use ingress and egress section. I will use this format. So it will be easy for me to understand that within the security group, I have following ingress and egress sections. This is for egress, which is outbound, which is outbound. If I change this to ingress, then that will be for inbound. Simply copy this section. First, let's create a security group. Copy this, paste it over here and make the changes. Here on the name, I will change it to some unique name, something like security group 1. Name, I can give SG1. For description, I will comment it now. VPC ID, let's copy it from previous sections. For tags, you can give the names. Just copy these tags and paste it here. Okay, let me copy from other section. Now we need to define the rules. Within this resource section, I am going to use the egress or ingress sections. Just copy this format. It's up to you. Okay. Paste it here. This is egress. That is outbound. Similarly, I will paste one more time. Here I will change it to ingress. So inbound and outbound. Here we are going to update our rule. But I will limit with my IP because nobody will access it. Generally, we will not give 0.0.0. So this will compromise our network. On this CAD block, I will change this to, if you see my existing default group, I have limited with my own IP. I will paste it here, which means allows all the ports only to my specific IP address. Nobody else can access this network from all the ports or from anywhere. Okay. We don't want IPv6 CAD block. Let me remove this. Okay. If you see this CAD block, it is a list because they have mentioned in a square bracket. So it is a list. So if you want to add multiple IPs, simply you can give comma and you can give n number of CAD ranges. What I will do is I will add one more CAD range. Generally we will give CAD ranges, okay, 10.series or some IPs. So similarly we need to follow the pattern. So here I will use, instead of specifying the CAD range manually, I will use the interpolation model. AWS underscore VPC.VPC1 dot, instead of ID, I will use the CAD block of my VPC. So if you see, I have used the CAD interpolation model. So it will go to the resource block and find the CAD block range, and that value will be applied over there. So from anywhere people can access it only from my IP and VPC range. So inbound is done. Egress, outbound is generally it will be open to all. It will not harm anything. So let it be default. For now, let's apply this. It's applied. Now let's refresh the security group. Coke SG1 is created. If you select this, under inbound, see there is a two rules. I have created only one ingress. On inbound, I have mentioned only one route. But here if you see, it has two resources. That is because on CAD block, we have mentioned two CADRs. For each CADR, that will create a rules. For my IP itself, it has created one rule. For CAD block itself, for VPC CAD block itself, it has created one rule. If you want to restrict with some specific port, you can give it. As I have given 0, it will be considered as all port. If you search for this somewhere they have mentioned if it is 0, it is for all. Only if you go through this document you will understand all this. So I am going to create one more inbound with restricting the port and protocols. Simply copy the ingress. Here in the shaded block I will give 0.0.0, which means anyone can access my network. But I will not simply leave this because I need to restrict it. For public subnet, it is a public web server. So obviously people have to access it through HTTP or HTTPS. Then only people can access it. That is why we mentioned this 0.0.0. Also we will specify the port. Simply we will not leave it to anyone. So from port I have to give only 80. So anybody can access to my network through port number 80. To port again 80. On protocol, as I said before, the protocol format is, let me simply search. On the protocol if you see -1, then it is equivalent to all. Doesn't matter TCP or UDP, it will be considered as a all. That is why we mentioned -1. Let me use -1 and apply it. In case of any issue, I will change this to any. Only that should support both port protocols like TCP and UDP. Then only you can use -1. If the port is not supporting both protocols, then there is no use of using it. Right? That is why we have got an error now. These are all network concepts. If you want to use -1, then both the ports should be 00. Then only we can use -1. Because it will have a combination of TCP and UDP. As we have used a specific port, I cannot use -1. Either you have to be specific with the protocol. You can mention TCP or UDP manually. Simply save this change and apply it. It is applied now. Let's again go back to security group and refresh it. Click on security group 1. If you see, we have one more rule added. For public, it is allowed to use only port number 80. This is how we add each rules. So security group is done. Now we need to deploy the servers. Web 1 will be deployed on public subnet and DB1 will be deployed on private subnet. For creating this EC2, already we have dedicated Terraform manifest file called ec2.df. Where we have a resource section. Already I have commanded it. So let me copy this, paste it over here, simply update it. If you want, you can take it from the registry as well. Okay, here just make the changes. Let it be web 1 and AMI using Ubuntu 20 and I am using AMI ID of Ubuntu 22 and instance type already I have referring some variable. It's where.my instance type. It is already mentioned in my variable section and it is T2 micro. In TFVAS also I have mentioned T2 micro. So automatically that will be applied. For subnet ID, this is web 1. So it should be on the public subnet. It is already mentioned. And here I have referred the interpolation order. It is already published at 1. Generally I follow the standard. In case it is different, just go through your resource section and find the right name and apply it. Here if you see, it is public_subnet 1. So I will use the same name here. It is correctly mentioned. And key name and associate public IP address. Yes, I need it. That's why I mentioned true. Then only I can access my server on public subnet through public IP. Generally I will be able to access it from outside. And security groups. The name is SG1. Again it is same. Tags. Simply copy the tags from previous section and paste it here and make the changes. It should be web 1. It's done. Just copy this resource. Again paste it for DB server. But here I will make some changes since it is a server to be deployed on private subnet. So just change the name. If you want to change any AMI ID or instance type, you can change it accordingly. and here on subnet it should be private subnet. Then only the subnet, the EC2 will be deployed on specific subnet. And since it is deploying on private subnet, I don't want public IP address. There is no use of it. So simply you can delete it. On tags, I will change it to DB1. Okay. Before applying this, I have an output section. So on terminal itself, it will display my IP or any other resources I want. Okay. So already I have mentioned in the EC2. So simply I will copy, paste it here. If you want, you can use this output section. We have already covered all these topics. So I am simply asking Terraform to show me the public IP of Web1 and private IP of Web1. So I will copy this output section again to list to show my private IP of DB server. DB server will not have a public IP, so I will use only the private IP. Okay, apply it. Meantime, you can go to instance. Okay, it is created for Web1 and DB1. It is created, and it has shown the IP of each EC2s. Let's open the putty and use the public IP or credential and use the key that I have mentioned in the resource section. Username is Ubuntu because I am using the Ubuntu AMI. Yes, I am able to log into server that is deployed on public subnet. I cannot access my DB server that is deployed on private subnet because that is not a public facing. This is how we have created the entire infrastructure. If I want to access my server that is deployed on private subnet, I can't obviously access it from my outside the network. I have to access it only from the public subnet. There is no public IP. Only I have a private IP. Okay, internally I can access it. So simply copy this IP. Just use ping and the server IP. See, I am getting the reply from private subnet server, which means internally I am able to access it. That is how the architecture was designed. And accordingly, we have created the Terraform manifest files. Also, I will install Apache for testing my security group port number 8. I have updated my package. So I will install the default Apache now. It is based on your application. I am just testing my infrastructure. Okay, let me restart the service. Okay, now if I access it, I am able to access my default Apache landing page. So completely we have created an infrastructure through Terraform manifest files. For this we have associated lot of resources. Hope you have got an idea. So definitely this topic will be very useful for you. I hope so. See you in the next video. Till then, keep practicing.
How did you feel? Is it helpful? Appreciate our efforts in the comment section below. Hit like button, share with your friends about us, subscribe our channel to get further updates. Stay connected with us on social networking sites. For more free tutorials, visit our website www.learnetguide.net.